Okay, students, it is very good that I am taking this problem, and we are going to discuss about this. This is about one-way ANOVA problem. Okay, so one-way ANOVA problem. So what is the problem about? Technicians and 5 days and their output is given in the following table. So these are the 4 technicians. Their output is given in the numbers, and these are 5 days. Okay, now let me expand this so that you understand the questions correctly. Now, first technicians in the first day, he is bringing out 6 output. Similarly, second technician in the first day brings 14 as output. Third technicians in the first day 10 output. Fourth technicians brings out 11 output in 5th days. Like that, what is given to us is about the output given to us. Now, what is the question? Is there any homogeneous behavior between technicians? Between technicians only. Okay, so this is a one-way ANOVA. Therefore, here technicians only we are checking here. This one-way ANOVA. Right. Now, what is our aim is that whether all the 4 technicians are working in a similar way, they are equally working or not. That's what we have to check up. And we know that the first step here is null hypothesis. The null hypothesis is that there is no significance difference between the technicians. There are 4 technicians, and we assume that all are equally working. So that's called null hypothesis. Second step is about alternative hypothesis. Okay, so alternative hypothesis, we must understand that alternative hypothesis is that exactly opposite to the null hypothesis. Opposite to the null hypothesis is alternative hypothesis, and there is significance difference between the technicians. That's what step number 2. And here there is no significant difference between technicians, and here we take the alternative hypothesis, that is, there is a significance difference between the technicians, and that's the step number 2. Now we are coming to step number 3, calculation of calculated value of F and table value for technicians. So for technicians, we have to find out what is calculated value or what is table value. Now look at that. In the given problem, all these are maximum or 2-digit numbers. Okay, so we have to square them and we have to add them on our way to get the answer. So it is better that to simplify the digits inside this box. So what I do, I subtract 10 from each elements in this particular matrix. I am subtracting 10 from each of the elements here. So what I will get now is that here 5 minus 10. 5 minus 10 is minus 4. That's what I have here. Similarly, 14 minus 10, what I will get is 4, and that's what I am getting here. Similarly, here 5 minus 10 minus 10, 0. That's what I am getting here. So like that, I have to do all subtract 10. I will get a new table like this. Okay, so this is what the new table I will get. This is a new table I will get. Okay, now what I have to do is that, now look at that, right. Now what I have to do here is that you add all of them and write here -4 plus 4 0 minus 1 minus 1, 4 minus 1 3, 3 plus 4 7, 0 plus 2 2 minus 5 minus 3, 5 minus 2 3, 1 5 6 7. So this is a way the row wise we have to add them and we have to write here. Okay, similarly we have to add the column wise also. -4 4, so total comes -1. If we add this, total comes 9, this total comes 5, this total comes 0. Okay, so this is the way that we can get this total value here. We are adding all of them, writing here, we are adding all of them, writing here, we are adding all of them, writing here, adding all of them, writing here, add all of them, writing here, add all of them, writing here, add all of them right here, and do the same for these two rows. Now next we have to, now look at that, u x1 square, that is you are squaring. -4 16, 4 square 16, 0 square 0, -2 4 square, 1 square 1. So this is a way x1 square we can get. Now x2 square that, you will get this column. Now look at that, 4 squared 16, 1 square 1, 2 square 4, 0 square 0, 4 square 16. So this is a way x2 square we can calculate. Now what about x3 square? So this comes from squaring this column. 0 square 0, 2 square 4, 3 square 9, 5 square 25, and 1 square 1. So this is a way we can get this column. Now last column comes by squaring this fourth column. 1 square 1, 2 square 4, 2 square 4, 0 square 0, 1 square 1. So this is the way we can get the last column. This column we can get. Okay, okay. Now if you add this, what you will get? If you add this, what will get is this semicolon. So you take this one, and if you add this, you will get this one. You add this, you will get, add this, you will get this, add this, you will get this. Now what is this capital N? Capital N is nothing but the total observation in the given problem. The total observations here is 1, I will take this one, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So the total observations inside this particular box is capital N. Okay, so now let me come back to the answer side, and this is what, so here is what we had, the capital N comes like that. Okay, now what about T? T comes from here. Now look at that, this is T. Okay, so from this T we get this. Okay, now the error term, how we can get the error term? T squared by N. So T is 13, so 13 squared divided by 20. 13 squared divided by 20, that's what, 13 squared divided by 28.45. Now the components of the box, the ANOVA box, we have to find out here. What is TSS? The formula is summation of x1 square plus summation of x2 square plus summation of x3 square plus summation of x4 square minus t squared by n. Okay, now the summation of x square, what is the meaning here? This is the summation. Let me cut, it's a square. This is summation, that is 37 summation x square, summation x square 37, so you'll get 37 here. So you are getting here, you substitute here 37, and this 37 you substitute, this 59 you substitute, this 10 you substitute here, and this is what is the error term that comes from here. Okay, where now SSC we have to calculate. Let me make it big. Okay, SSC, we know the formula. SSC is equal to summation of x1 square divided by n1 plus summation of x2 square divided by n1 plus summation of x3 square divided by n1 plus summation of x4 square divided by n1 minus t squared by n. Okay, now let me now look at the table here. Summation of x1 square, this is x1 square, summation is minus 1, therefore minus 1 the whole square. Now summation of x2 square, this is x2 square, summation is what, 9, so 9 square divided by 5. 5 means 1 2 3 4 5. This we have to count and we have to write here, that is n1, not n1 here, n2 n3 n4 should come there. The next number, summation of this is 5, so 5 square divided by, how many elements are there? 1 2 3 4 5, so that 5 we are writing here, minus the last one is 0 square divided by 5 is 0, minus t squared by n. T squared by n is how much? 8.45, that you are writing here. The answer is 12.95. Therefore SSC is 12.95. Okay, so we have to note that, so here SSC is equal to 12.95 and TSS is equal to 114.55. Now what is SSE? SSE equals TSS minus SSS. Now let me make, so SSE equals TSS minus SSC. Okay, right, so TSS is how much? 114.55, that is what TSS. Now what is SSC? SSC is 12.5, this is 12.5, you subtract, you will get this. Okay, therefore SSE is equal to 101.6. So we have got SSC value, we have got SSE value, we have got SSC and TSS, and we are substituting those values in this particular table. Okay, so let me substitute those values here in the particular table. We have to minimize so that I can show the values here. Yes, now we know this very clearly. This is one-way ANOVA table. So first is between the columns and SSC, how much we have got it, 12.95. okay, then C is number of columns. How many columns are here? 1 2 3 4 1 2 3 4 columns are there. So 4 minus 1 equals 3. Now what is MSE? Mean square column wise equals SSC, that is 12.95 divided by C minus 1 is 3. So 12.95 by 3 equals 4.32. okay. Similarly, what is SSE? SSE we have 100 and 1.6. So 101.6. What is N minus C? N is total number of observations. We have, this is 20 minus number of columns 4. 20 minus 4 equals 16. From this, what is MSE? This we have to divide by this. SSE divided by N minus C, that is 101.6 divided by 16 is equal to 6.35. okay. Right, what is the next now? Next is that among this MSC and MSE, which is the maximum number, that number you have to write at the top. The minimum number we have to write it down. So among these, MSE got 4.32, MSE got 6.35. So MSE is greater number. That greater number you are writing on the top, that is in the numerator, and MSE is small number, that you are writing under that, that is in the denominator, that is 4.32. And this value, divide this by this, you will get 1.47. This is what calculated value of F column wise. So calculated value F for column wise, calculated value F for column wise 1.47. 1.47. Now let me find out the table value here. That's also very important. Am I right? So table value, how to find the table value? Now look at that. Before that I have to maximize it so that you understand the fact. Now afterwards we'll come over here. Now this is the column gives you the table value of F for 1% level. You note that in the questions they are not asking any level. Am I correct? So we can take 5% level or 1% level. So if you take 1% level, note that the numerator, here the numerator is MSE. Its degrees of freedom we have to write first. So MSE is in the numerator, its degrees of freedom is 16. So FC 16. The denominator MSC, so MSC is here, its degrees of freedom is 3. That you have to write here. Remember there, look at this particular fraction. The fraction, the numerator is MSE, its degrees of freedom we have to write first. So MSE is here, its degrees of freedom is 16. So you are writing 16 here. Now come to the new denominator MSC, its degrees of freedom is 3. That you have to write here. Okay. So for this we have to find out the table value. The level is 1%. Okay. Now look at how to find out the table value. I will explain you now. Now in your algorithm, what can I say is that statistical table, F table will be given there separately for 0.01 level as well as 0.05 level. Okay, 2 levels it will be given. So but here we are taking only 1% level, therefore 0.01. In this particular table, so there would be a vertical line like this. vertical line like this and horizontal line like this. In the horizontal line, the degrees of freedom will be given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. Here also the degrees of freedom will be given on the vertical line 1, 2, 3, 4, 5, 6 like that. Now for this particular case where we are taking here as f of 16, 3, the 16 you have to write, numerator you have to write in this particular direction, that is in the horizontal direction, and the second number here or the denominator you have to take in this direction. Okay, so here 16 you take in this direction, 3 you take in this direction. The intersection of these two, a point will be there, and that point is the f table value for the given situation. Therefore f table value for 16, 8 is 26.9. okay, 26.9. so this is a way you have to find out the table value there. Okay, right, now let us go back to our problem. I will discuss. So what's next step? To find out the table value. Table value for 16, 3 is equal to 26.9. That is what I was just explaining. Now the comparison of the calculated value of f and table value of f. Calculated value of f and table value of f. Here what is calculated value of f is equal to 1.47 and table value is 26.9. Okay, now we are comparing them. When we compare, we see that calculated value of f is less than table value of f. Okay, so if that is the case, we must accept h naught, and we have to accept h naught. In some cases, this calculated value of f may be greater than table value of f. In that case, we have to reject h naught. H naught means our null hypothesis that we make here. So what you see in this problem, the calculated value is less than the table value. Therefore h naught is accepted. That's what you have to understand. Very important point here. The h naught is accepted. That means what? Conclusion. Conclusion is that h naught is accepted. That means there is no significant difference between the technicians. That means all technicians are equally working. They are homogeneous behavior. So there is no significant difference between the performance of 4 technicians. Okay, so there is a homogeneity. That's what we understand. Okay, so this is a way we have to solve this one-way ANOVA. Okay, so first step is that we have to write the null hypothesis. There is no significant difference between technicians. Technicians means column wise. Second step is that there is a significant difference between the technicians. Third step, we have to calculate FC and FT by using this calculation. And it's better that we have to simplify the given matrix, because we have to square it, we have to add, so it may be difficult for us. Therefore we have to simplify these the entries. Okay, so that's what we do here. Then afterwards we are squaring and adding. Here we are adding, rating total, we are finding out NT and SSC. Okay, these are SSC, we are finding out SSC, SSC by using the formula, TSS, SSC by using this formula. We are substituting in this particular formula, in this particular table, ANOVA table, and we would have the FC value here 1.47, and also the table value for this will get 26.9, and then we are comparing them, and if this is the case, h naught is accepted. If it is greater than the case, then h naught is rejected. So the conclusion comes according to that. If it is accepted, there is no significance difference. If it is rejected, then there is a significance difference. Like that we have to do one way ANOVA. Okay. Thank you very much.